Hello again, Gen Chem students. Let's talk about those buffers some more. Go over to the notes. All right, we had previously discussed what a buffer was, what was its purpose, and basically some calculations. But now let's see how a buffer actually works. So what would happen if I added things to the buffer, and how would I choose which buffered system to use? So I'm going to go over to the whiteboard. All right, first of all, what is a buffer? A buffer is the combination of a weak acid with its conjugate base or a weak base with its conjugate acid. What is its purpose? Is to resist changes in the pH. And two, what is the nifty thing? We can use the Henderson-Hasselbalch equation with moles instead of molarity. Okay, so that was kind of the take-home point of the previous one. Well, now I want to know what happens when I add something to it. So the first one we're going to look at is adding an acid to the buffer. All right, so I'm just going to use the numbers that we had previously. So we had acetic acid, and these numbers might be backwards, but it doesn't matter. And 0 point, I think that was a 2. All right, so this is the buffered system that I'm starting with. I am going to add, okay, I'm going to add 3 mils of 0.1 molar HCl, strong acid to it. All right, step number 1 has not changed. I still have to come up with a balanced equilibrium expression. So what is going on? Okay, this is what is in my beaker. This is what I'm adding to it. I need an equation that says what will happen when they hit each other. And so that begs the question, well, if you throw protons at this solution, what is it going to do? And if you'll notice, protons are part of the original equation. And so those protons, if you add in the extra, is going to react some of the acetate, and it should shift left, and it should shift left. Now I'm just going to write a new equation that represents that. So my acid is going to use up some of my acetate, and in a consequence, it's going to make some more acetic acid. Well, how much is it going to use up? Ooh, am I still buffered? Okay, so the question is, if I'm still buffered, I can be in moles. So I'm going to assume right now that I am still in moles, and so I'm going to convert this into moles, and I get 0.1233. Oh, double check that on my calculator. 3 zeros and a 3. Yep. So that's how much I added. I originally had 0.00200 moles of acetate, and I originally had 0.00150 moles of the acetic acid. So in this case, I know how much acetate I'm going to use because my question is, do I have enough acetate to sop up all of those protons? And the answer is yes, I have more. Well, then how many are you going to use? I'm going to use all of them. And when I use up some of that acetate, it's going to create some acetic acid. Oh, so I have enough. I used up all my protons. And how much acetate is still left? 0.002, and I'm left with 0.0017. And I added, you see, 1, 2, 8. Yep. Okay. So after I added that extra acid, this is what's still floating around. Am I still buffered? And the answer in this case is yes. So I can still use my Henderson-Hasselbalch. So pH is equal to 4.74 plus the log of the base piece. Okay, now I don't care where it's written in the problem. It's the base piece over the acid piece. So 0.0017 over 0.0018. Ah, my new pH is going to be take the log of that, so 0.94. Now notice that's not the negative log, that's just the log, and then I'm going to add that to 4.74. And I now have a 4.72. All right, my new pH is now 4.72. Oh, so did I expect that? All right, here's the interesting thing. This is not where it started. Okay, the pH of this beginning solution was not 4.74. The original pH, I guess we can calculate it really fast up here. The original pH was, I believe it was 4.87, but let's calculate it. The log of the base piece. My original was 4.8, and depends on the rounding, but 4.86. So the pH initial is 4.86. Well, my pH now is 4.72. So what happened to it? So I went from 4.86 to 4.72, so it decreased. Okay. Well, did I expect that? Well, yeah, because I added acid. But did it decrease by a lot? Okay, if it's a buffer, it shouldn't have changed by very much. And if you'll notice, a 0.1 unit, hey, that little buffer did pretty good when I threw strong acid at it. All right, so the second pH was 4.72. All right, well, let's ask it what would happen if I added base to it. Now, in this case, I'm going to add it to the original. Okay, so I'm going to pretend I haven't added this acid. If I wanted to go next, I would use these numbers. Okay, so if I was just going to keep going, but I'm telling you, go back to the original buffer and let's add some base to it. All right, well, how much base do you want to add? Hmm, hmm. Let's add 5 mils. Yeah, 5 mils of 0.1 molar sodium hydroxide. Okay, let's throw a strong base at this thing. Okay, can you tell me what the sodium hydroxide is going to do? Now, it's not already part of this equation, so I'm going to have to look and see who it's going to react with. So the sodium hydroxide is, yes, it's going to react with a little teeny amount of that proton. But who has more protons? And it's going to be the acetic acid. So my hydroxide is going to react with my acetic acid, and in consequence, it's going to make some water and some acetate ions. Well, how much acetic acid did you start with? Okay, I think I'm still going to be buffered, so I'm going to stay in moles. So 0.00150 and 0.00200. And then that begs the question, how much sodium hydroxide did I add? So my 5 mils converted should be 3 zeros, 1, 2, 3, and a 50. Okay. All right. So right here, 0.1235. Hey, acetic acid, do I have enough of you to sop up or to neutralize, to react with whatever word you want to use? Is there enough acetic acid to use up all that hydroxide? And 0.0015 is larger than 0.0050, so the answer is yes. Well, then how much are you going to use? Well, I have enough to use all of it. So that's how much I know to subtract. And as I use up some of my acetic acid, I'm going to create some of my acetate. All right, so that went to 0. This one goes to 1, 2, 3. Haha, I can do that without the calculator. 1, 2, 1, 0 moles. And then over here. All right. Am I still buffered? Okay, so if I want the pH, I have to plug it into some kind of equilibrium expression. Am I still buffered? And the answer is yes. I still have the acid and the conjugate base pair, so I don't have to go back out to molarity and use the equilibrium expression. I can use the Henderson-Hasselbalch version of it. So pH, and that's what I was saying, how it saves time. Because in these calculations, I'm already in moles, and I don't have to go back and forth with all my diluting. Let's see, so who's my base piece? 0.00250 all over 0.00100. And so my new pH after adding my base to it is 0.00251. Take the log and add that to 4.74. My new pH is 4.14. Did I expect that? And remember, I'm not comparing to this. I'm comparing to what my pH started. So my pH started at 4.86, and now I said 4. I meant 5, sorry. Make that calculation correction. The pH is 5.14. So originally I started at 4.86, and now I'm 5.14, which means the pH went up because I'm becoming more basic. Did I expect that? Well, yeah, I threw some sodium hydroxide at it. So it used up some of my acid, so the resulting solution has to be partially basic. So that is why it's really nice to be able to use moles in the Henderson-Hasselbalch, is once you convert to moles, every time you add something, you don't have to go back and redo dilution problems each time. Now, there's nothing wrong with that. Okay, if you're more comfortable with that way, absolutely. But if you recognize a buffered system, it's usually easier to be in moles for the calculations. All right, let's do another example. All right, so let's take benzoic acid. All right, and then I can look up the Ka off of the chart. But if I want to make a buffered solution, I need to add which two pieces? I need to have some of this one, and I need to have some of this one. Okay, go to the shelf and whatever you have, put the two together. But let's just say I did 10 mils of, I'm so boring. I always use the same thing. And let's use 15 mils of the sodium benzoate. Okay, now, in order to plug it into the ice table, I need to either be in molarity, or if I'm buffered, I can use moles. And I'm recognizing that this is the acid and the weak base conjugate pair. So I'm going to use the shortcut and I'm going to go straight to moles. So if I convert this one to moles, I should come up with 0.2 zeros and a 1. So 10 divided by 1,000 times 0.1. Yep. So 0.00100 moles and 0.00150 moles. Okay, so that's my original buffer. So I now have 25 mils of my buffer. I have 25 mils of it. Well, how many moles are floating around in there? 0.001 moles of the H-bin and 0.0015 of the bin minus. Okay, let's do something to it. Let's add, let's use blue. All right, so these are going to be my questions. 1, I'm going to add 5 milliliters of 1 molar sodium hydroxide. The next one, let's do add, let's just change the number up, 4 mils of 1.5 molar HCl. And then let's go really wild and crazy. The next example, let's add 15 mils of that 1.5 molar HCl. All right, now I'm telling you, these are not on top of each other. So I want you to consider the question starting from the original amount. Okay, so let's add 5 mils of 1 molar sodium hydroxide. Well, that begs the question, if I add sodium hydroxide to this, what piece is it going to react with? And the answer is yes. I know it's going to react with a little bit of the protons that are present. But of those that have actual, quantity around, who's it going to react with? Oh, it's going to react with that one. So my hydroxide will react with my H-bin, and in consequence, it will make some water, and it will kick out some benzoate. Well, how much sodium hydroxide did I throw at it? I think I'm going to be buffered, so I'm going to convert to moles. So that's 5 mils of 1 molar. And so 5 mils converted to liters, and that's 0.005. How many zeros is that? 5 divided by 1,000 times 1. Yep, it is 0.0050 moles. Well, how much benzoic acid did you start with? I only started with 0.00100, and I started with 0.00150 of my benzoate. Do I have enough of my benzoic acid to react all of that hydroxide? And in this case, the answer is no. So I'm not going to use up all of the hydroxide. I'm going to use up all of the benzoic acid. Okay. All right. Let's subtract 0. Well, how much benzoic acid did I have? I had that much. And when I react it, I will convert that over to benzoate. Okay, so this time my benzoic acid goes to 0. And how much of this did I use? Let's see, 0.00400 moles and 0.00250 moles. Okay, so that's what I have left over when I'm done. Guess what? No more buffer. Okay. I can't use the Henderson-Hasselbalch because I don't have a buffer left. So I overwhelmed my buffer. And so what's really floating around? I have 0.004 moles of strong base, and I have 0.0025 moles of weak base. Who's really going to control my pH? Now, I could go and do the equilibrium for the weak base, but if you have a strong base, it's going to control. And what do you do to a strong base? You just take the negative log of it. Ooh, except I can't take the negative log of a mole. I have to take the negative log of a concentration. So I have 0.00400 moles of extra hydroxide, and my volume right now is I originally had 25 and I added 5 to it. So I have 30 milliliters, okay, which I have to convert out to liters. And so what concentration of hydroxide is actually floating around in my solution right now? 0.004 divided by 0.03. I have 0.133. And how many sig figs do I get? Yeah. 0.133 molar strong base, or I could say sodium hydroxide. That's what's floating around in my solution right now. Oh, so if I take the negative log of it, my pOH is 0.875. How many sig figs? 0.875. Remember, that's the pOH. So the pH had better be very basic. And add 14 to that, and I get 13.125. Woohoo! Yep, I don't have a buffer anymore. I overshot, and now I have a basic solution. Huh, okay. Now, I was just making up those numbers, so I'm going to change it for my next one. Instead of doing 1.5 molar, I'm going to make it so I don't use up my buffer. So I'm going to say 0.150 molar solution. Okay, so there's the first problem done. What would happen if I added 5 mils of 1 molar sodium hydroxide to this existing buffer? Well, I'd overwhelm it, I'd use up all of my H-band, and I would be left with 0.133 molar sodium hydroxide, and the pOH should be 0.875, and the pH should be 13.125. All right, new question. Starting with your original buffer. Let's see what happens when I add that acid. And green. Okay, so if I add acid, who is it going to react with? Okay, so this time I'm adding acid, and it's going to react with the Ben minus. So those protons will sop up some of my Ben minus, and in consequence, it'll make some more weak acid. And how much acid did I throw in there? So 4 milliliters convert to liters, and then 1 liter. And then I made this change so it won't overwhelm it. So it's 0.150 molar. So I added in 3 zeros and a 6. 1, 2, 3, 6, 0. Double check. Yep. Okay, so that's how much acid I added. Well, how much Ben minus did I start with? And how much H-Ben did I start with? Okay. Do I have enough Ben minus to sop up all of that acid? Yay! In this case, because I changed the number. Yes, I do. So how much of it are you going to use? Well, I'm going to use all of it. And in consequence, I will make some more benzoic acid. So I'm going to use up all of my acid. So how much of my Ben minus or my benzoate do I still have? I have 0.30 and a 9. So how many sig figs? 1, 2, 3, 4, 5 after. 1, 2, 3, 4, 5 after. Okay, so that's how many moles of the Ben minus I still have. And 12160 moles of my H Ben. All right. Did I overwhelm my buffer? No, because I still have buffer left. If I have buffer left, I can just use the Henderson-Hasselbalch. So the pH is equal to, okay, now this is not acetate, this is benzoic acid. So I'm going to my reference sheet and I'm looking up benzoic acid, and benzoic acid is 6.3 times 10 to the minus fifth. So the Ka is 6.3 times 10 to the minus fifth. So the pKa is 4.20 plus the log of the base piece. Okay, and remember, I don't care where it's in the equation. You always put the base piece on top. Divided by the acid piece. And divide those out. And add that to 4.2. Woohoo! 3.95. 3.95. Okay. Did I expect that kind of a pH? Remember, this is not where it started. So let's just do a little check. Where did we start? So up here, the pH would have started at 4.20 plus the log of 0.00150 over 0.00100. Okay, so before I did anything, it was add 4.2. It was originally 4.38. Okay, so my initial pH was 4.38. Well, now it's 3.95. So what happened to it? Okay, I actually went lower in pH. So I became more acidic. Did I expect that? Well, yeah, I'm the one that threw the acid at it. I'm the one that threw the acid at it. Okay, but did it act as a buffer? Did it resist changes to the pH? All right, we dropped from 4.3 to 3.9, but it's still buffered, okay? It didn't drop like plummet into the negative pHs or anything. So yes, the buffer did its job. And then last but not least, let's overwhelm the buffer again. So we saw it overwhelmed with base. Let's see it overwhelmed with acid this time. All right, so this time we're going to add 15 mils of a 1.5 molar HCl. Well, how much did I start with? Okay, let's see. So 15, I'm going to convert that to moles. So 15 divided by 1,000 times 1.5 is 0.0225. All right. Well, I'm throwing acid at this buffer. What piece of the buffer will sop it up, or what piece will use it? Well, if I start with an acid, the base piece has to use it up, and in consequence, all right, and I started with 0.0225 moles of my acid. I started with 0.00150 moles of my benzoate and 0.00100 moles of my H-Ben. Do I have enough benzoate to sop this up? And the answer is no. Oh, sad. So how much can I use? Well, I can only use as much acid as I have benzoate. So that's how I know what to subtract from it. The one I have the least of. Oh, I'm going to use up all of my benzoate. But I do get to add a little H-ben, 0.00250 moles. And how much of that extra acid is floating around? 0.00225, 0.0015. I'm left with 0.123, No, that is not right. 0.0225 minus 0.0015 is 0.021. Zero 0.0210 moles are left. Am I still buffered? No, I cannot use the Henderson-Hasselbalch, so I need to look what in the world is going on. I have excess strong acid, and I have some weak acid. Who's going to be controlling my pH though? It's not the weak acid. It's going to be the strong acid. Well, if you have a strong acid, you can just find its concentration and take the negative log of it. Aha. Means I have to get out of moles back into molarity because I can't take the pH of a mole. And so right now that begs the question. I have 0.0210 moles of my extra protons floating around. What volume am I right now? So I originally had my 25 and I added my 15 to it. So right now, 2, 3, I have 40 mils total. Convert that over to liters. And I have 0.04, 0.525. So I have a 0.525 molar solution. Hey, I started with a 1.5, so my buffer did something. Okay, but I have a 0.525 molar solution. Double check that again. 0.021, 0.04. Yep. And then I'm going to take the negative log of it. And my new pH is 0. How many sig figs? 3. 0.2798, so 0.280. Whew, that dropped pretty low. Did I expect it? Well, yes, because I overshot by a lot of strong acid. A lot of strong acid. All right, just a little side note. Well, what pH was the original acid by itself? Okay, so if I take the negative log of the 1.5, because it's strong, I don't have to worry about equilibrium. 1.5, the negative log, it was a negative 0.177. So my original acid, that 1.5 molar, was a pH of a negative 0.177. And at least now I'm at 0.280. Okay, so I dropped my solution pH from 4.38 to 0.280. It overwhelmed my buffer and there was excess acid. But it's not as acidic as just the plain 1.5 molar. Whew. Okay, in a nutshell, those are 3 calculations. But you need to know to a buffered situation, you need to know what happens if you add acid to it. You need to know what happens if you add base to it. And I'm not going to do the calculation because we don't need to, but what if you just add water to it? Well, buffers, if you dilute the acid, you're also diluting the base. So if you add water, okay, it has no change. Throw all the water you want at buffers. It should not change anything. All right, so you should be able to now come up with an equation for what would happen if you added acid to your buffer, what would happen if you added base to your buffer, and if you come out, okay, so after you've added, Is it still buffered? You may use the Henderson-Hasselbalch. Okay. Oops. Okay. Yes, it's still buffered. No. Okay. So whichever one you're in excess of, the excess of the strong convert back to molarity and take the negative log. And that will tell you your overshoot. Okay, so I call that an overshoot or excess. All right, kind of a long video, but that is what you would do with the addition of acid and base to your buffer, and technically water. All right, until next time, Jolly out.